3,
You want to learn now?
1. Nice.
I want you to learn now. So, 7.8, number 14.
What?
Says we need to evaluate exactly, without a calculator, cosine inverse of 1/2.
It's 1/2.
That one is 1/2.
Yep.
Because the cosine and the cosine inverse undo each other, right?
Yep.
Okay. That seems legit. However, cosine inverse of cosine of 5 pi over 3 is not quite that easy. Why?
Because it's not a standard angle?
No.
No, it is a standard angle.
It is a standard angle.
Is there the cosine inverse of the cosine?
But it's that
Not
one
going to
thing.
get you what you started.
Yeah, remember cosine inverse is only a partial inverse, right? It works when cosine inverse is on the inside, but not when cosine inverse is on the outside.
Right.
So it's possible here that I'll end up with something that's a little bit like a reference angle.
So wait, just to clarify, it's because the range of a cosine inverse is smaller than the domain of cosine?
Yes, that is identically the reason.
Cool.
Very nice.
It has
So-
less than one.
Here I have cosine of 5 pi over 3, which I could maybe figure out. But maybe let me just sort out where is 5 pi over 3.
Isn't it like 3
More
times?
low.
So
So 5, 5.
for those of you who have been saying that your pre-calculus is, or your trig is a little rusty,
3, 6, 30.
no, shut up, Levi. Not Levi. So, how many pi over 3s is 5 pi over 3?
5.
It is 5 pi over 3, right?
But what's the significance?
Okay. Good question. How many pi over 3s make 1 pi over 3? Or 1
3.
pi?
5. 3.
3. So instead of thinking about this as 5 pi over 3, we could think of it as 3 pi over 3 plus 2 pi over 3. Right?
And then
Which is a pi.
Yeah.
So where's the angle pi?
180 degrees.
That's 180 degrees, right? So we go here, that's pi. Then where do we go for 2/3 of a pi?
270.
How far is 2/3 of a pi?
It's just one more.
Isn't 2 pi
2/3
3 times?
120 degrees.
2/3 of a pi, right?
Yeah.
So you think of, here's 1/3 of a pi and there's 1/3 of a pi. I need to go 2 of those, right? So that's one of them and another. So that's a pi and a pi over 3 and a pi over 3. Do you see this?
That's
Yes.
2, 3 times.
So what's the cosine of this thing?
It's going to be
-1.
positive
1.
because it's going to be
Half.
So here's the angle you're talking about, right?
Yes.
So here's the triangle we're talking about.
So 1.
And so this is in a unit circle, right?
Yeah. So 1.
Oh,
Why?
cosine.
this is 1. The hypotenuse in there is
Oh,
1.
because it's a 30, so that's a square root 3. 2. Wait, 45. So it's a 1. That's a square root 2.
Okay, so on some level at least, we should be thinking about the 30, 60, 90 triangle,
Okay.
right? Which is, I think, what you're doing. So you're saying, okay, the 30, 60, 90 triangle has a 2, a 1, and a square root of 3.
That's,
Which sides are which? Or which angles are which?
Hypotenuse is 2.
well, there's a 90.
Yeah. There's a 90.
The 30 is up in the top.
And, okay, so I'm working in radians. What's 30 in radians?
Pi over 6.
Pi over 6. And that makes this one a pi over 3.
Mm-hmm.
Oh, so this triangle is just kind of upside down from the one I want over there, right?
Right. So.
You guys see that? So if I kind of think this triangle at that thing, I'm thinking,
Square root of 3 over 2.
okay, so I'm looking at this and I'm thinking this is pi over 3, right?
Okay, so
Except it's not actually pi over 3, it's
30 degrees.
no, that's still 60 degrees. But pi over 3 would be that way, right?
Negative.
Negative.
So this would be negative pi over 3.
Yeah.
with that.
Yeah.
And then at this 1, I'm kind of thinking 2.
Right, because of the triangle.
And then the side opposite the pi over 3 side is a
Root 3.
root 3. So at this side, I'm kind of thinking root 3. And at this side, I'm thinking.
2. 1.
So if I want the cosine, which side is that?
X.
That's the x side. So that would be
1/2.
1 divided by the hypotenuse. Got 1 over 2. See that?
Mm-hmm.
So my claim would be that this part here,
Oh,
oops, that's the worst
Someone read it.
squiggly bracket ever,
No, no.
should be 1/2.
Thank you.
And then what's the cosine of 1/2?
What is going on here?
You got 3. Wait,
What's
what?
the cosine of a half? Oh wait, sorry, what's the inverse cosine of a half, brother?
Yeah, pi over 6.
Should be pi over,
3. Oh, I thought
I think pi over 3.
yeah.
So out of this, I got pi over 3. What the heck is that about?
So the inverse cosine is just the angle and radius. Hang on.
Yeah, so the inverse cosine is going to be an angle, right? And they gave me an angle in radians, so I should probably give them back an angle in radians.
Okay.
See that?
Yeah.
And why is it not the 5 pi over 3 they started with?
It's not within
Because the 5 pi over 3 wasn't in the range of cosine inverse. So where's the range of cosine inverse on this picture? Yeah, cosine inverse's range is up here, right? The angle's between 0 and pi. So you're only going to get something between 0 and pi out of this thing. So this is saying, what's the angle that's most like 5 pi over 3 between 0 and pi? You guys kind of see that?
Yeah.
So keep in mind when you do a cosine inverse to a cosine, you're getting kind of a reference angle thing, not an actual, not a cancellation. That help?
Yeah.
Yeah?